Today we're going to learn section 4.2, trigonometric functions of acute angles. Acute angles are angles less than 90, and trigonometric functions are sine, cosine, tangent, cotangent, cosecant, and secant. Those are the 6 trig functions that you've learned in previous math classes. If theta is an acute angle in right triangle ABC, then the following relationships occur. So here is theta. It's an acute angle. Mark the angle that we're using. So we're using theta. And then after that, identify the parts of this triangle, the sides with relationship to theta. So I would always look for the hypotenuse first. The hypotenuse of a right triangle is opposite the right angle. So there's the hypotenuse. Now if we look at this side compared to this angle, this side is opposite this angle. This side with the relationship to this angle is adjacent. Adjacent means next to. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. So these 3 trig functions you've learned probably in geometry. Now, when you find these 6 trig functions, again, write it in this manner. Write it in this order. Because this is cotangent, this is secant, and this is cosecant. Cotangent is the reciprocal of tangent, opposite over adjacent, and then that's adjacent over opposite. Secant theta is the reciprocal of cosine theta. So notice, adjacent over hypotenuse, secant is now hypotenuse over adjacent. And cosecant theta is the reciprocal of sine theta. Sine is opposite of hypotenuse. Cosecant is the reciprocal, hypotenuse over opposite. Now, the way to remember these relationships is what we call SOHCAHTOA. The reason why we teach you to remember SOHCAHTOA is so you can remember the relationship of sine, S for sine, O for opposite, H for hypotenuse. That's why we call it SO. Sine is opposite over hypotenuse. Cosine, C, cosine, is adjacent over hypotenuse. Well, adjacent over hypotenuse. And tangent, to remember tangent, think of TOA. Tangent for T, O for opposite, A for adjacent. So SOHCAHTOA. Once you memorize the relationship of sine, cosine, and tangent, you will know what cotangent, secant, and cosecant are. As long as you write it in this order, these will always be reciprocal of this. Alright, so that was a quick review on your previous standards in your other math classes. So now it says find all 6 trig functions of angle theta. Remember, this is theta. Alright, so now let's take a look at this triangle. Again, this is a right triangle, therefore I can use these relationships. Again, what you want to do is mark the angle. After you mark the angle, identify the hypotenuse. Well, here's 90 degrees. I know this is the hypotenuse. This angle with relationship to this side, that is the opposite. This is the opposite side of this angle theta. So that means this is the adjacent. Adjacent means next to. So now that we have theta and we labeled our triangle, we can remember SOHCAHTOA. So sine is opposite over hypotenuse. So here's sine theta, opposite over hypotenuse. Okay. Cosecant is a reciprocal. Cosecant is a reciprocal. So if sine theta is 8 over the square root of 100 over the square root of 113, then cosecant is the square root of 113 over 8. Again, if you always write it in this order, you'll know that these are reciprocals. Next is cosine, the c. Cosine is adjacent over hypotenuse. So cosine theta is 7 over the square root of 113. Therefore, secant is the reciprocal. It's the square root of 113 over 7. Tangent, TOA. So tangent is opposite over adjacent. So opposite over adjacent, 8 over 7. Therefore, cotangent is 7 over 8. Again, because these are reciprocals of each other. All right. Next, we have example 2. Example 2 says, evaluate the remaining trig functions given tangent theta is 12 over 13. Okay, I'm going to review with you how else you can remember the relationships of sine theta, cosine theta, and tangent, along with cotangent, secant, and cosecant. Whenever you see sine theta, think y. Whenever you see cosine theta, think x. And tangent theta will always be sine over cosine, y over x. So once again, sine theta, always think y. Cosine theta, always think x. And if you know sine, cosine, and tangent, we know cosecant, secant, cotangent, because we know that these trig functions are reciprocal partners of these trig functions. So what they gave us tangent theta is equal to 12 over 13. What we have to do now is, well, we have to find the other 5. Well, I know one we could find right away. We could find cotangent theta right away. Because if we know tangent, we know cotangent is the reciprocal. So the reciprocal of 12 over 13 is 13 over 12. Okay, well, we know our x, we know our y, but we need to find r. So what we have to remember is these relationships can only occur when we have a right triangle. So if we have a right triangle and we know what x and y are, well, we could find r. And here's your Pythagorean theorem. X squared plus y squared equals r squared. X is 13, y is 12. So I'm just substituting. I need to find r. So when you calculate everything, r is the square root of 313. So r is the square root of 313. So we have our r, we have our y, we have our x. Well, now we just substitute all our values in. We said y is 12. So that's 12 over, r is the square root of 313. Well, if sine theta is 12 over the square root of 313, then we know cosecant is the reciprocal. Square root of 313 over 12. Cosine is x over r. Well, x, right? X is 13. And r is the square root of 313. Well, if cosine is 13 over the square root of 313, then secant is just the reciprocal. So that is example 2. Given one trig function, we were able to find the rest without even using a graph. Just remember, sine, think y. Cosine, think x. If you can memorize sine and cosine, you can generate the other 4. So memorize sine and cosine, you can get the other 4. All right, that's example 2. example 3. Example 3 is secant theta equals 17 over 5. Well, we know again, this is r over x from our previous example. It's r over x. Okay, so if this is r over x, well, we just have to find y. If we could find y, then we could find all 6 trig functions. So we're going to use the Pythagorean theorem again. X squared plus y squared equals r squared. X we know is 5. We don't know y, we know what r is. So after you calculate everything, y is going to end up being 2 square root of 66, because I simplified this. So after subtracting 25 and taking the square root of 264, it ends up being 2 radical 66. So we have y, we have r, and we have x. As long as we know those 3 variables, we could find sine, cosine, tangent, cotangent, cosecant, secant, and cotangent theta. Well, this is what we know. If secant theta is 17 over 5, we know what cosine is. Cosine is going to be the reciprocal, 5 over 17. We know sine theta, remember, sine theta was y over r. Well, we know y, that's 2 radical 66 over what's r? 17. So sine theta is y over r. Tangent, again, from the first page, tangent is y over x. Well, we know y, 2 radical 66, x, what's x? X is 5. Well, if I know tangent, I could find cotangent because, again, they're reciprocals of each other. So this is 5 over 2 radical 66. If we know sine, we know cosecant. This is the reciprocal. So 17 over 2 radical 66. So we found all 6 trig functions by just one given piece of information. Okay, so the key is understanding those relationships. Sine, think of y over r. Cosine, that's x over r. Tangent, that's y over x. Again, we could find these 3 as long as we know these 3 first, because then we just take the reciprocal. All right, I'm going to review with you some special right triangles. So again, make sure you pause this video when you have to take notes. So special right triangles. This is what we call a 45-45 90-degree triangle. So the reason why this is a special triangle is because we already know the ratios of a 45-45 90-degree triangle. So again, sine 45, let's just mark 45 degrees. Label hypotenuse, opposite this 45, adjacent. So remember, SOHCAHTOA, sine 45 we said is opposite over hypotenuse. So that's 1 over radical 2. Now when we simplify this, to simplify radicals, to rationalize the denominator, you just multiply by radical 2, and now you have radical 2 over 2. So another way to write this is radical 2 over 2. Cosine 45, the ca, that's adjacent over hypotenuse. 1 over radical 2 again, and that's radical 2 over 2. Tangent, TOA, opposite over adjacent. So that's just 1 over 1, which is 1. All right. So again, to find these 3, we just take the reciprocal of these 3 respectively. So Cosecant 45 is just a reciprocal of 1 over radical 2. I'm going to use this one, so when we take the reciprocal, well, look what happens. We don't have any radicals in the denominator. Secant 45, again, is the reciprocal, radical 2 over 1. And 45 is the reciprocal of 1, which is just 1. So again, these are special right triangles. It's special because it's a 45, 45, 90. Okay, next we have our 30, 60, 90. So now I want to find the ratios of 60 degrees with all 6 trig functions. Again, it satisfies the requirement. That's an acute angle. It's in a right triangle. So mark up the angle we're using and identify the hypotenuse. And then this side related to this angle, that's the opposite. And this is adjacent. So now sine 60, well, sine 60 is right? Opposite of hypotenuse. So opposite of hypotenuse, radical 3 over 2. Cosine is ca, adjacent over hypotenuse, 1 over 2. And tangent, toa, opposite over adjacent, radical 3 over 1. It's not necessary to write 1, okay, because it's still the same thing as radical 3. All right, well now let's find the other trig functions. So that is going to be 1 over radical 3. And again, to adjust this here, 1 over radical 3, what you're going to do is you're just going to multiply by radical 3, radical 3. So we have radical 3 over 3. Okay? Because for these special right triangles, I don't want radicals in the denominator. Secant 60, well, it's just a reciprocal of cosine 60, so that's just 2 over 1, just 2. And this is radical 3 over 2. Oh, no, reciprocal. So the reciprocal of radical 3 over 2 is 2 over radical 3. So let's adjust that. 2 over radical 3, again, multiply by 1. This is 2 radical 3 over 2 radical 3 over 3. Okay. So now you have found the 6 trig functions for 60 degrees. All right. Next one. Let's look at let's look at 30 degrees. So again, mark up the triangle, identify, label all the parts now. I would always label the hypotenuse first, and then from here, how is this angle related to this side? Well, it's the opposite. How is this angle related to this side? It's the adjacent. So sine, opposite over hypotenuse, 1 over 2. Cosine 30, ca, adjacent over hypotenuse, radical 3 over 2. And toa, opposite over adjacent. But again, we already know how to fix this because we did it here. So that's radical 3 over 3. Again, I don't want radicals when it comes to these special triangles. Okay, so now to find these trig functions, it's just the reciprocal. So that's 2. That's 2 over radical 3. But we know what it is from here because we adjusted it already. Remember this here? It's 2 radical 3 over 3. So this is, let me squeeze this in, 2 radical 3 over 3. Cosine 30, well, that's 1 over radical 3. So, I'm sorry, cotangent 30, 1 over radical 3 is tangent 30. Well, it's the reciprocal. Okay, so now you have found the 6 trig functions for 30 degrees. Now, I also want to mention to you that sometimes the book will use degrees, sometimes the book will use radians. Well, by now, we know how to convert degrees to radians. So to convert degrees to radians, remember, it's the degree, given degree, times pi over 180 degrees. Well, if I convert this to radians, the degrees reduce, so now you're left with pi over 6. So on your homework, sometimes you'll see sine 30. Other times you're going to see this. You're going to see sine pi over 6. So know what to do, that if it's sine 30, it's the same thing as saying pi over 6. This is also going to be pi over 6, and it's the rest for all of them. Let's do this. 60 degrees converted to radians. Again, the degrees reduce, so now you're left with pi over 3. So sine 60 is the same thing as saying sine pi over 3. And it's the same for cosine 60. That's cosine pi over 3. And the last one here, 45 degrees. Again, if you convert that, that's going to be pi over 4. So 45 degrees is the same thing as saying pi over 4. So just understand that, remember, degrees and radians are just 2 different ways to measure an angle. Alright, that's it for example 3 and the review of special right triangles. Alright, let's discuss example 4. Example 4 is evaluate without a calculator. Well, what we know is cosecant pi over 6. We just talked about that. So when we talk about pi over 6, here's pi over 6. So cosecant pi over 6 is 2. Well, that's your answer, just by looking at this. Now, what I do know, what we could have done was, well, we could have referenced sine pi over 6. Sine pi over 6, we know, is 1/2. Right? Sine pi over 6 is 1/2. Well, isn't cosecant and sine reciprocals of each other? So that's why cosecant pi over 6 is 2. Let's look at secant pi over 4. Well, pi over 4, that's the 45 degree. So secant is radical 2. But I know cosine pi over 4 is 1 over radical 2. If that's 1 over radical 2, I know this is just the reciprocal. Okay? So, again, understand how to interchange degrees and radians, because you're going to do it often with this chapter. Alright, next, evaluate with a calculator. Well, all you do is you just take your calculator and make sure this is degrees. So just put mode, and there it is. You're in degree mode. So once that's highlighted, clear that, and then now you could just push tangent 8 degrees, close it, and that equals roughly 0.141. Alright, here is radians. The reason I know this is radians is because I see the pi symbol. So whenever you see the pi symbol, that means we're talking about radians. Alright, so adjust it. So go to mode, and now switch to radian mode. Put radian mode, clear this, and now you could evaluate that. Sine, let's go with, remember, second arrow, pi divided by 15, close, and that's going to be roughly 0.2 0.208. All right. So again, with this, you're just adjusting your calculator. All right, example 6. Example 6 says, find theta. Okay, so we have to find sine theta. So I know that if sine theta is equal to radical 3 over 2, remember, this was y, this was r. This was, remember these relationships from example 2. Sine theta is y over r. So that's radical 3 over 2. So we have to figure out what angle this is. Well, to figure that out, draw your right triangle. And this is a 30, 60, 90. I know the reason why it's a 30, 60, 90 is because it's radical 3. Once you see radical 3, we know it's a 30, 60, 90 degree triangle. So this is y, this is r. So where is y? Here is radical 3. This is the y. This is the r. So that means this is the x. So sine, when we think of sine, we think of y over r. So y over r, well, we could look at it this way. This is, if we have y and r, this is going to be opposite over hypotenuse. Okay, or we could think of it as adjacent over hypotenuse. But since we're thinking sine, remember what I said? Think of y. So I'm going to use this relationship. I'm using sine, I think of y. So remember, this is now opposite over hypotenuse. Well, if I'm using opposite over hypotenuse, it's this angle we're thinking of. So theta is equal to 60 degrees. And in your homework, they might ask you for radians. Well, we already converted 60 degrees to radians. That is also equal to pi over 3. So again, the way I did this was, I know sine theta is y over r. So there is y, there is r. Once I know y over r, I know we're dealing with sine. Sine is opposite of hypotenuse. Therefore, it's 60 degrees. All right, let's look at secant theta. Secant theta is r over x. So secant theta is r over x. Well, we know this is r, and x, let's see, x, we can think of this as our x, because here's a 1 here. There's an invisible 1. So either one can be x. Let's just make this x. Well, if I say secant is r over x, that means theta is 45 degrees. And that is equivalent to pi over 4. All right. So another way you could think about this is secant of what angle gets us a radical 2, and it's pi over 4. All right, last example, or next to last example. It says solve for the variable. So this is going to be, here's z, here's our unknown. So I'm going to mark this angle. Mark this angle. This is opposite, hypotenuse, adjacent. So the way to do this problem is, well, what has adjacent and hypotenuse? Is it the so, the ka, or the toa? So that's how you have to think about this. We have adjacent hypotenuse. I'm going to use cosine. So I'm going to say cosine 39 degrees is equal to adjacent over hypotenuse. Well, now all we're going to do to get z by itself is I multiply by z on both sides. So this z will reduce. So now I have z cosine 39 degrees equals 23. Divide by cosine 39 degrees. And now z is equivalent to, again, just get your calculator. 23 divided by cosine 39. And then you'll roughly get 29.595 degrees. Okay? So that is z. Oh, no, I'm sorry. Not degrees. It's 29.6. We're looking for a side, not an angle. Sorry about that. So it's 29.6. That is the hypotenuse. And the answer makes sense because 29.6 is more than 23. Okay, next. Identify the angle, then label. That's the hypotenuse. This side is opposite. This side is adjacent. Well, they want us to look for x. So now we have to figure out what trig function has opposite over hypotenuse. Opposite over hypotenuse, that's sine. So this is sine 43 degrees equals x over 14. Opposite of hypotenuse. To get x by itself, I multiply by 14 to both sides. So now x is roughly, just put that in the calculator, put 14 times sine 43, and that's roughly 9.5. So we found the variable. Okay, and the last lesson today is we're going to solve triangle ABC. So to solve triangle ABC, they gave us this picture. This alpha, remember, we're using Greek letters. I'm not going to put these Greek letters. I'm just going to use A, B, and C. So they gave us angle 41. They gave us angle C. Well, angle C is 90 because that's a right angle. And then they gave us side C, which is 10. Whenever they say solve right triangle, whenever they say solve triangle ABC, they just want the missing parts. So we could actually find angle B because there's a definition out there that the sum of all the angles in a triangle add up to 180. So angle B is equivalent to saying 180 minus 90 plus 41. So this is going to be 180 minus 131, and that's going to be 49 degrees. So that is 49 degrees. To find these sides, we'll just use our trig functions. So I mark the angle that we're going to use. So this here's your hypotenuse, right? Opposite 90 is the hypotenuse. Opposite this angle, well, that's the word opposite. And next to this angle, that's adjacent. So again, if I want to find A, we're going to use opposite over hypotenuse. Opposite of hypotenuse. So what has opposite and hypotenuse? It's our sine function. So sine 41 degrees equals opposite over hypotenuse. Okay. So now all we're going to do is multiply by 10 on both sides. And now 10 times sine 41 is roughly 6.6. All right. To find out, we're just missing B now. Well, let's use this trig function, adjacent over hypotenuse. Adjacent over hypotenuse. So between SOHCAHTOA, it's cosine. So cosine 41 degrees equals adjacent over hypotenuse 10. Okay. And again, multiply both sides by 10. The 10's reduced, so B is roughly 7.5. Now before we're done with this problem, we just solved it. We found all the parts of the triangle. Now make sure it makes sense. The largest angle is 90 degrees. The longest side better be C. And it is. The smallest angle is A. Well, this is the smallest side. So again, there's a property in geometry that states that if the largest angle is 90, or if this is the largest angle, this better be the longest side. If this is the smallest angle, this better be the shortest side. And everything corresponds with each other. All right, that's it. Have a good day.